This is video 19 using pySerialTransfer between Raspberry Pi OS and Windows 11. The code for this video is at the GitHub site. These videos on Python should work as well on any Raspberry Pi OS board. All code examples have definitions at the beginning of the file to allow the user to alter as needed. As this channel covers multiple small systems solutions over time, please subscribe to stay informed and click like, as that really helps. In this video, we deploy the pySerialTransfer package to a Raspberry Pi and configure its Bluetooth hardware as Serial Port Profile, or SPP. We then connect it to the Windows 11 Bluetooth Virtual COM port. Let's jump forward in time and watch a demo. I'm using Visual Studio Code to view the Python code and run the programs. On the left is my Windows 11, and on the right I've remoted into the Raspberry Pi. I took a copy of the example code from the website for the package for the pySerialTransfer 2.6.9. So if you come to this site, you'll see an example Python script. I've copied this script into the Visual Studio Code for the Windows 11 and for the Raspberry Pi. You'll see that this uses an example COM port, so we've had to modify just that one line in order to configure it for our setup. All right. So on the Windows 11, I've configured, as you will find out, COM port 50 as the virtual COM port. On the Raspberry Pi, we will be using /dev/rfcom0, which is the Bluetooth serial port for Raspberry Pi. Now this port does not exist until the Windows connects to the Raspberry Pi. Then this will appear on the system. So in order to make that happen, we have to begin our application on the Windows 11, and then the device will be initiated on the Raspberry Pi, and we can connect to it. Okay, as you can see, the example program immediately starts exchanging data between the two. Let's stop it and look and see what it's doing. Okay, in the Windows 11, I'm using the example code as is. On the Raspberry Pi, though, so that we could see the difference, I've modified slightly the value of the list from 1,3 to 2,4. I changed the hello string on the Raspberry to world, and I changed the floating point value from 5.234 to 12.234 so it'll stand out. Okay, since we started the program on the Windows 11, it's going to send 1,3 hello 5234 to the Raspberry Pi, and as you can see here, it's received it. Meanwhile, the Raspberry Pi will send the 2,4 world 12.234 to the Windows 11, which is why you see this in the received section of the printout. Okay, and then it just iterates this over and over again. And the only thing I did additionally was I added a 2-second sleep on both of the programs so that the data didn't come out so fast. All right. Now that we know it works, let's look at how we configured everything. We begin on the Raspberry Pi by configuring a serial port profile in the Bluetooth service. I do this by commenting out, locating the exec start and commenting it out. And then adding the two lines. The first part of the line is very similar to the one that we are replacing, but the second part is what's adding the SDP tool, which provides a serial port over the Bluetooth. Now we just save it and exit. At this point, you would reboot the computer. We're in the Raspberry Pi operating system now, and we begin by going in the upper right hand corner and looking for the Bluetooth wizard, and we want to make the Bluetooth discoverable on the Raspberry Pi. After starting that, we click the add device and we let the wizard begin searching for any local devices. And we select the MIDI computer that just appeared, and we click pair. This is going to send a code to the PC. So we must go over to the PC and acknowledge the code by clicking on the yes on the dialog, and come back to the Raspberry Pi and agree that that's correct. And now we have paired the two devices. So you can see the desktop is now available through Bluetooth to the Raspberry Pi and vice versa. Back on the PC, I go to the settings. I go to Bluetooth and devices. I click on devices, and then I scroll down, and I'm looking for more Bluetooth settings. Here it is. I'll click on that, and when I do, I'll get a Bluetooth settings wizard. What I want to do is click on the COM ports. When I do, it's going to show me a list of COM ports, virtual COM ports. And I'm looking for the outgoing port number. So COM47 is the serial port we need. Back on the Raspberry Pi, we need to open a terminal. Type in the command sudo rfcom watch HCI0 and press the enter key. Just like the demo, the Raspberry Pi now waits for the PC to connect. Continuing on the Raspberry, in a new terminal, I activate a virtual Python environment. Here I'm using Conda that I installed earlier and created an environment called P311, which is Python 3.11. Then I pip install pySerial. And I pip install pySerialTransfer. You'll see that I've already installed these earlier. All right. Notice that we're using pySerial 3.5 and we're using pySerialTransfer version 2.6.9. We can get a copy of the example code from the GitHub site. In my browser, I made sure that I'm looking at pySerialTransfer version 2.6.9. If I scroll down, there's an example Python script. I want to copy this script in its entirety to my Raspberry Pi, and I will also copy it to my PC. Now that I have the Bluetooth configured, I can edit the example code. In the left screen, I have the Visual Studio Code showing a file on the PC, and in the right screen, I've remoted into the Raspberry Pi, and I'm showing the example code file on the Raspberry. On the Windows PC, I need to modify the first line and change it to the port number that we found when we looked at the Bluetooth settings. In this case, the outgoing port is COM port 47. To verify the code, I could add a command that I'm showing in this file that will do a loopback test exactly on this PC. On the Raspberry Pi, I need to modify the COM port and replace the COM port 17 with /dev/rfcom0. As you recall, we have a separate terminal running on our Raspberry Pi that is watching for a Bluetooth connection. And when it does, it creates this device, rfcom0. It does not exist until then. So in order to get it to show up, I must start the program on the PC, which will attempt to connect. And when it does, it creates that watcher will create the div RFCOM. And so then I can run the program on the Raspberry. First, since I'm in the remote PC, I want to activate my virtual environment in the Raspberry Pi as well. Okay, let's start the program on the PC. So I'll type in Python and then the name of my test file. And I forgot to save. Okay, now it's running port COM47. I'll come over and run the Python program on the Raspberry Pi. And when I do, you'll see that we're getting the programs to run just like we did in the demo. Let's stop it and take a look. Okay, as before, the printout occurs on the PC first. It's going to send 1,3 hello 5234 based on the example code to the Raspberry Pi, which receives it, as you can see here in the first line, and the Raspberry Pi is going to send back 2,4 world 12.234, which is then received by the PC. So that's it. We've easily configured the example code using the pySerialTransfer library. Instead of the interactive RF command that we used on a Raspberry Pi terminal, we can set up a RFCOM service that watches the Bluetooth adapter and creates the /dev RFCOM0 device for us when a connection begins. We do this by going out to the Raspberry Pi and using the editor to create the RFCOM service in the same system folder as before. It looks very similar to the command, especially this line for the service, but that's it. Simply write that out, exit, and start that service using the system CTL program as before, and you will be working with your Raspberry Pi from your PC at any time. In summary, we can easily modify the Bluetooth service to provide a serial port profile for classic Bluetooth on the Raspberry Pi, and it just connects on the PC. We can then install pySerial, which is the Python serial library, and we can install the package pySerialTransfer on both the Raspberry Pi and the PC. And then we can use it as is. We only need to tweak the program slightly, which is to add the proper COM port on the system that it's running on. We can then use it to exchange data between a Raspberry Pi and a PC system. Thank you for listening.